Okay, this is the day 10 lesson. Yet another review on nth roots and fractional exponents. Let's get started. Looking at problem number 1. If I were you, I would recognize that this is a negative exponent. And if you have a negative exponent, that means you are on the wrong side of the invisible fraction, which is here. And so this is going to wind up being dropped down to the bottom. Okay, so if I do that, that means up here I'm just going to have a 1. But down in the bottom, I'm going to have negative 343 to the 5 over 3 power. That would be my first step. There are other ways to do it. This is the way I'm most comfortable with. Now, the next thing to do is to convert this to radical form. So, in radical form, alright, I've still got that 1 up there, but the 5 is the power, the 3 is the root. So this would then be the cube root of negative 343 raised to the 5th power. Okay, 5 is the power, 3 is the root. Now we need to do the cube root of negative 343. Well, first of all, don't worry about the fact that it's negative. That just means the answer will be a negative number. So just ask yourself what the cube root of 343 is. Okay, so if I want to do the cube root of 343 is 7. Okay, so this is going to give me 1 over, now I have 7 to the 5th power. But it was negative 343, so that means the cube root will be negative 7. So now I just need to do negative 7 to the 5th power. Okay, don't leave it like this when you have a table. When you have an odd power, a negative number will stay negative. So I know this is just going to be negative something. So just a matter of what 7 to the 5th power is. So 7 to the 5th power is 16,807. So 16,807. So this will be your final answer for number 1. Alright, number 2 is already in radical form. Let's see if 59,049 is a perfect 5th power. Let's see, 59,049. Okay, so the 5th root of 59,049 is 9. Okay, so that means inside of the parentheses here, I simply have 9. 9 to the negative 2 power. Now, once again, a negative exponent means you are on the wrong side of the invisible fraction. So I'm just going to take that and drop it down. And once again, that means up here I'll have a 1, and down here I'll have my 9 squared. That will give me my final answer of 1 over 81. Okay, that would be your answer number 2. Okay, number 3. Well, notice that we have the same exponent here. If the exponents are the same, I can go ahead and do this division and just keep the exponent the same. So, take your bootleg 4-function calculator, nasty, and go ahead and do, let's see, 32,768 and divide by 8. I get 4,096. So that means I have 4,096 to the 3/4 power. This is a 4. Let me try that again. That was a little bit of a fail. Better. Again, this is power over root, so I will go ahead and convert this to radical form. So this is a 4th root because of that 4. So the 4th root of 4,096. and then 3 is the power, so that'll be to the third power. Hopefully this is a perfect fourth power. Alright, fourth power, and there it is. So the fourth root of 4096 is 8. So this will become, everything in here just becomes 8. So I just have 8 to the third power, which I believe is 512. Yes, 8 to the third power is 512. And that is your final answer for number 3. Now, take a look at number 4. Notice this negative sign is way out here. It's outside of the parentheses, so I'm just going to leave that negative sign way over there minding its own business. In the meantime, inside the parentheses, what's going on? Well, once again, this has a negative exponent. That means it is on the wrong side of the fraction. I'll have to drop it down. So this is going to become 1 over 36 to the 5 over 2 power. The negative sign is still sitting there. Okay, so now I just need to evaluate this. So let's see what we got. So I've got this negative. Now I'm going to go ahead and convert this denominator to radical form. So I've got 1 over. Now 2 is the root. So that is the square root of 36. Okay, and 5 is the power. So that's going to be to the 5th power. So square root of 36 to the 5th power. So as I go ahead and do that, let me wrap it around up here. So I've still got the negative, still got the parentheses, still got the 1 over, but I have the square root of 36 is 6. So that means I have 6 to the 5th power. So this is pretty much done. I really don't need the parentheses anymore. It's just going to be negative whatever I got. It's just a matter of what 6 to the 5th power is. And 6 to the 5th power is 7,776. So including that negative sign, this is your final answer for number 4. Alright, number 5. Be careful. Even though there's no parentheses showing you that this negative sign is definitely not in it, automatically this exponent does not include the negative sign. Unless there is a parentheses and the negative sign is on the inside. I don't even see an example of that. But this negative sign will not be included on the inside of this problem. So please understand that this negative sign is just going to sit out in front, minding its own business, similar to the way that this negative sign did. Okay, in fact, on problem number 4, these parentheses didn't really change anything. Even without the parentheses, this negative sign would have had to sit there the entire time and nothing would have happened. Okay, so we just have to evaluate this, and whatever we get, we're just going to stick a negative sign on it. So let's do our radical form, but notice that negative sign is not under the radical. So this will be the 4th root and the 5th power. Okay, so I got to do the 4th root of 12,096. Okay, and then I'm going to do the 5th power of that. Negative sign is not in it. So I'm hoping this is a perfect 4th power. Let's check it out. 4th power. Boom, there it is. So the 4th root of 1,296 is 6. Kabam. So that means this is going to become, all right, everything inside of here is just going to become, whoops, little slip there, is going to become 6. And then we still have the 5th power. Let me just double check that again. Yeah. Okay, so I'm doing the 5th power. So 6 to the 5th power, 6 to the 5th power, oh, didn't we just see this? Again, 7,776. So your final answer will simply be negative 7,776. Kabammy. Whammy kabammy. Okay. Number 6. Now, for number 6, this one's strange and interesting. I see these bases, if you will, are the same, but the roots are not the same. So I cannot just straight multiply these or anything because the roots are not the same. What you really need to do is convert these to exponent form. Okay, so for example, the 6th root of 5 is the same thing as 5 to the 1/6 power. The 3rd root of 5 is the same thing as 5 to the 1/3 power. Now hopefully you see that when you multiply with like bases, you add the exponents. So what we're doing is we're doing 5 to the 1/6 plus 1/3 power to the 8th. I'm going to do this off to the side like I do. So if I have 1/6 plus 1/3, when you're adding, this is when you need like denominators. If I multiply this by 2, then they'll both be 6s. So that's cool. So I'm going to have 1/6 plus 2/6. 1 plus 2 is 3, so that's 3/6. And this reduces to 1/2. Okay, keep that in mind. So I would have 5 to the 1/2 power to the 8th power. Okay, let's just make a note that this 1/2 came from this process. Now, power to a power, you multiply. So this is going to be 5 to the 8/2 power. Okay, remember, this is just like 8/1. So 1 times 8 is 8, and 2 times 1 is 2. So that's what happened there, but it's ugly, so I don't like it. And I'm sure you're waiting to tell me that 8/2, Mr. Burton, that's just 4. And you're absolutely right. So that's 5 to the 4th power. And we're not going to leave it like that when we have a table to use. 5 to the 4th power is 625. So that will be your final answer for number 6. Kabam! Okay, let's see what's going on here. Now, we can get rid of these parentheses. Look, the bases are not the same, nor are the exponents the same. So I can't divide anything or anything like that. I can't start subtracting 3 minus 1/3 or anything like that. So I have to go ahead and perform this exponent and this exponent. I have to do it. So let's see what that makes. 8 to the 3rd power is what this is, okay? 8 to the 3rd power is, I believe it was 512. Let's see. 8 to the 3rd power is 512. So, so far we've got 512. Okay, and then obviously x to the 3rd power is just that, x to the 3rd power. Now, I need to do the 1/3 power to both of these things. Now, focus on the 8 for a second. Maybe I'll do this off to the side. I have to do 8 to the 1/3 power, right? Sort of like this. But please understand that 8 to the 1/3 power is the same thing as the cube root of 8. And we all know that the cube root of 8 is 2. And if you don't, use your chart. Cube root of 8 is 2. So 8 to the 1/3 power is 2. So let's not even waste time. Let's just go ahead and put 2. Okay, so 8 to the 1/3 power is 2. And then when I do the variable part, I need to multiply. 2 times 1/3. So that's going to be 2/3 as my exponent. And remember, what I'm doing is like 2/1. So it's 2 times 1 and 1 times 3. So that's 2/3. So this is what I have so far. Well, not exactly. I forgot the x. I'm multiplying these, but this is x to this power. So let me make room for my x. Sorry about that. So it is x to the 2/3 power. So this is what we have so far. Now, I can go ahead and divide the 512 and the 2, okay? So you see that's 256. So, so far I've got 256. Now, if I want to divide x to the 3rd power by x to the 2/3 power, when you divide like bases, you subtract those exponents. So that's going to be like doing x to the 3 minus 2/3 power. So all I really have to do is figure out what 3 minus 2/3 is, and we're good. So I will just do that right here. All right, so if I do 3 minus 2/3, well, that's like having 3 over 1. So I need like denominators, so I could just multiply by 3. Okay, so that would give me 9 over 3 minus 2 over 3. 9 minus 2 is 7, so that is 7 over 3. Okay, so that gives me my final answer. So I will have 256 x to the 7 over 3 power. All right, how about number 8? All right, let's see if we can evaluate the inside part first before we get too carried away. So converting to radical form inside of here. So this 3, the denominator is the root. So I've got the cube root of 27, and then that's going to be to the 4th power. Okay, and all of this is raised to the negative 1/2 power. Like on this entire thing, I've got negative 1/2 power on it all. Okay, just because there's too many parentheses, I'm going to erase this pair. All right, you get it. It's the cube root of 27 to the 4th power. All right, the parentheses are bugging me. So let's go ahead and do the cube root of 27. Of course, the cube root of 27 is just 3. Now, if you did not know that, cube root 27, 3. But now I have 3 to the 4th power still. All right, in fact, let me tighten this up a little bit. All right, and I still have this negative 1/2 power hanging around. But 3 to the 4th power is 81. Okay, see, 3 to the 4th power is 81. So I have 81 to the negative 1/2 power. Okay, this is not going to be negative 9 or anything like that. That's a common mistake. Remember, like you've seen so many times before, a negative exponent means you are on the wrong side of the line. So I need to take this and drop it low. Okay, if I do that, let me recopy. If I do that, I'm going to wind up with 1 over 81 to the positive 1/2 power. Okay, and hopefully you know that 1/2 power is the same thing as the square root. Okay, just like 1/3 power, same thing as cube root, like we talked about before. So this is the second root, the square root of 81, which we know is 9. So the final answer is 1 over 9, 1/9. Notice it is not negative, okay? A negative exponent does not make it a negative number. It just drops it down. Okay. As we look at number 9, I have the 6, the 3, the 8. Those are all different. But what's the same is the exponent. if the exponents are the same, you can do the multiplication and division with the bases. So let's go ahead and do the numerator first. Okay, if I do this, 6 times 8 is 48. So I will have 48 to the 3/4 power. Okay, you just keep that exponent the same. And so far I didn't do anything with the denominator, so it's still 3 to the 3/4 power. Okay, now here again, the exponents are the same. If the exponents are the same, you can go ahead and do the division with this 3 here. So 48 divided by 3 is 16. Alright, so you watch 48. Whoops. See, Brianna made me type it in wrong. But I just say 48 divided by 3, 16. See, just like I told you. So let me just write this down. So it'll be 16 to the 3/4 power. Alright, so now we can just evaluate this by converting to radical form. Now remember, 3 is the power, 4 is the root. So 4th root of 16 is kind of how we begin the form, 4th root of 16, and then that 3 is the power, so that'll go on the outside like that. 4th root of 16 is 2. Alright, if you did not know that, you would just do this. 4th root of 16 is 2. And then 2 to the 3rd power is 8. So that is your final answer. 2 to the 3rd power is 8. So that's it for number 9. Number 10, let's take a look at this. Alright, now these roots are the same, so that means I can go ahead and multiply 4 times 8. So I have the 5th root of 32. That sounds familiar. Let's take a closer look at the 5th root of 32 on the chart. 5th root of 32. 32 is a perfect 5th power. And the 5th root of 32 is 2. Okay, so this will just become a plain old ordinary 2. Alright, and then 3 times 2 is 6. Alright, so I have 6 to the 2nd power, which is 36. So kabam, there you go. Alright, how about number 11? Well, let's can we reduce this? Alright, I think our best bet is to split this apart, because I don't think this will really reduce at all. So please understand that the 4th root of some big old fraction is the same thing as the 4th root of the numerator over the 4th root of the denominator. Okay, now one of these is a perfect 4th power. Which one is it? 625 is right there on the list. So I can do the 4th root of 625. The 4th root of 625 is 5. So that means I'm going to have, go ahead and wrap this around early. So I have the 4th root of 162 over 5 so far. Okay, that just became 5. Now, this could be the answer unless we can simplify this a little bit more. Okay, 162. We're dealing with the 4th power. So I've got 81 and 16. I need to see if either one of these will divide evenly into 162. Okay, so turns out 162 divided by 81 is 2. Alright, that means I can rewrite 162 as 81 times 2. So let's do that. Let's, instead of putting 162, let's put 81 times 2. I wrote 81 in pink because I can do the fourth root of 81. Fourth root of 81 is 3. So because it's right here on the list, I'm going to put it in pink. So I can do the fourth root of 81 and bring it outside of the radical. So this 81, the fourth root of 81 is 3. Now everything in blue is just going to stay where it is. Okay, so this became a 3 on the outside, but I still have the fourth root of 2 still sitting there, and I still have the 5 sitting there. So that is all you can do. Alright, that would be the final answer for number 11. Alright, how about number 12? Let's see, what do we have? 64, blah, blah, blah. Alright, I'm just going to leave this alone for a minute. Later on, I'll be dropping that A down, don't you worry. But later. Let's deal with simplifying this. So I've got the fifth root. Now I've got the 64. 64 is not a perfect fifth power. However, 32 is. And I know that 32 times 2 is 64. So I can rewrite 64 as 32 times 2. Now for the variables, I really want this exponent to be divisible by 5. 6 is not divisible by 5. But I can rewrite a to the 6th power as a to the 5th power times 1 extra a, like that. Now everything in pink here is going to simplify and come out in front of the radical. So the fifth root of 32 is 2. So I'm going to have 2. Alright? For the variable, I just divide. Like 5 divided by 5 is 1. So I'll just have a from that. So that's the pink stuff. Now the blue stuff is just going to stay what it is. So I've got the fifth root of 2a. So that takes care of all of this. Now I still have negative 7a to the negative 3 power over here. So let's sort of put this together. Negative 7 times 2 is negative 14. Now when I put these a's together, I'm adding the exponents. So this is like a to the 1 power. So negative 3 plus 1 is negative 2. So this will be a to the negative 2 power. Alright, and I've still got the rest of it. Fifth root of 2a. Now, as we've seen many times before, if you have a negative exponent, you are on the wrong side of the invisible fraction line. And you must drop down. So, that's going to set me up for my final answer, which is negative 14 times the fifth root of 2a over a squared. That's all you can do. Alright, so there's number 12. Put the pencil down. Do this by yourself later. What was I saying? Oh yeah, number 13. We've got to break it down, people. You've got to break it down. I don't see any other way. Now when I look at that 10 and I'm looking at the sixth root situation, well, we don't even rock sixth roots, but even the fifth root, there's no number that's that small. All right, 32 is the smallest. It just doesn't get this small. So I'm looking at the 10. That's too small to do anything with that sixth root. Therefore, I will leave it alone under the radical. Sixth root 10. Now, when it comes to the variables, we need exponents that are divisible by 6. Less than 10, that's only 6. Alright, 6 and 4 make 10. So I split up this x to the 10th power as x to the 6th and x to the 4th. Yeah. So then I have y to the 11th. I'm going to split that up. Again, y to the 6th is the first thing that you get to under 11 that is divisible by 6. And that is going to leave 5 y's left over. 6 and 5 make 11. Then the z's, man, the z's. The z's are great, just the way they are. Z to the 12th. 12 is divisible by 6, so we are ready to go. Everything that's shown here in pink is going to simplify and come out. This will become x. I'm dividing by 6. Similarly, y to the 6th power will become y. The z will become z squared on the outside. 12 divided by 6 is 2. Alright, that's going to leave everything in blue. 10 x to the 4th power, y to the 5th power. This is my final answer. Oh yeah. Number 14. Look at this mess here. At least in the numerator, these roots are the same. If the roots are the same, you can go on ahead and multiply. So what I have next is negative 4, just brought that down, times a cube root. Now y squared times y to the 5th is y to the 7th, because you add those exponents. So this is what I have so far. Okay, then I've got this. Square root of 64y to the 8th power. Both of these can be simplified. The square root of 64 is 8. And the square root of y to the 8th is y to the 4th power. Okay? That's because when you do the square root, there's an invisible 2. It's the second root. So we're doing 8 divided by 2, and that's where the 4 is coming from. We will certainly reduce the 4 and the 8 here, right? 4 goes into itself once, 4 goes into 8 twice. So far, that gives me negative cube root y to the 7th power over 2y to the 4th power. Now, and to finish this problem, because we really want all the y's to be in one place, not some y's in the top and some y's in the bottom. So to put them together, we're going to need to convert this to exponent form. So let me wrap around. I see 7 is the power and 3 is the root. So I could rewrite this numerator as negative. Let's see, I could use a fractional power. Whoa, I didn't mean to put that negative on there. Power over root. So that is 7 over 3. And then down here I've got 2y to the 4th power. Now hopefully you can guess what I'm going to do with the y's next. To divide like bases, I must subtract the exponents. So off to the side, please understand that if I do 7 over 3 minus 4, that's what's happening here. In fact, let me just show one extra step. When I subtract, so basically I will have negative y to 7 over 3 minus 4 power all over 2. Okay, I'm subtracting these. To divide, I subtract. So I just need to figure out what this is. Back to green. Well, first of all, 4 is like having 4 over 1. So if I want like denominators, and I do, I'll multiply by 3. So that's going to give me 7 minus 12 over 3. 7 minus 12 is negative 5. So I've got negative 5 over 3. Okay, so that's going to happen right here. So I'm going to get negative y to the negative 5 over 3 power over 2. So I'm almost done, but now that I see that it's a negative exponent, I really need to drop this down to the bottom. Alright, that makes this problem a little bit tricky. But in the end, because it's a negative power, I'm going to have to put it in the bottom. So this is going to become, and I'll have to leave a 1 up there to kind of hold the spot. So I'll have negative 1 over 2 y to the 5 over 3 power. This would be the final answer. Okay, it looks like we're down to the last problem. Alright, well, might as well put this stuff together a little bit. These roots are the same, so I can go ahead and multiply here. So that is going to give me, so I've got 2 to the negative 3 power. I'm just going to leave that for now. And I will have my 5th root. Alright, now x to the 4th times x to the 6th. That is x to the 10th, because I add those powers. And all of this is to the negative 1 power. Yeah, so I've got 2 to the negative 3 power still. With variables, I'm going to divide, so 10 divided by 5, so that'll be x squared. Alright, now both of these have powers, so I have a powers raised to a power. So I'm just going to multiply both of these by negative 1. So that'll give me 2 to the positive 3 power and x to the negative 2 power. I just went ahead and multiplied. Now, in my final step, I will move anything that has a negative exponent. So here's the invisible fraction line, and this is on the wrong side of it. So I've got to drop it down. Okay, so I have my 2 to the 3rd power over x squared. Of course, 2 to the 3rd power is 8, so the final answer is 8 over x squared. Alright, I hope this video was helpful, and I will see you on the next video.